Hmm? YouTube. Inform them. Join as fast as possible. Inform Rupa. Link read and send me. I'm sending Rupa. They are not listening. Yeah, they're not coming regularly. Also, very irritating. Hmm? Yeah, send Rupa. Join. Hi, Tanisha. Rupa, let's send fan off. Yes, Tanisha. Last class we were talking about electrolytes, positive and negative electrolyte we were talking about. Hi, Aru. That day test you have written or not? Score you got or not? That day you got score or not? Test written, score got. Say, today again test is there. Score you received or not? You say that one only. You received score? Okay. Inform in group that still now you did not receive score. They'll give you score. Inform in group that you did not receive score, they will give you score. Fine. Now listen, we'll go back to our work, please. So last class we were talking about electropositive and electronegative ions. Huh? So in that, everyone, those who have not received score, please kindly inform in the group that you submitted in the group and you did not got score. No, no, you don't send me. You don't send me. Correction department, yes, correction department is different. Question department is different. Every department is different. When the questions already solution everything is given. So all departments are different. Yes, the correction department is different. They will be correcting and they will be giving it up. Yes. So we start work, please. Today also you will collect. You'll get score. You'll get score. Now listen, shall we start our work please? So now look here. So we were talking about monovalent, bivalent, electropositive, and electronegative elements. So we have a discussion about what is the meaning of electropositive element, what is the meaning of electronegative element. We had a discussion about electropositive and electronegative elements. Okay. Now what we are going to talk about, like electropositive elements are, now come on, get a very quick recap and try to understand this one. So now let's start. First question I'm going to ask. Answer the question. Electropositive gives electrons or takes electron? Very good. Electropositive is giving electron. Super. So when they are giving electron, they are called as cation or anion. Very good. Cation is positive or negative? Very good. So cation is positive, cation is giving electrons. Super. My next question is, yes, you need to be very, very fast and start answering the question. The cations are positive. Yes, absolutely correct. The cations are positive. The next question coming from my side is, if I want to stable myself, yes, if I want to stable myself, to whom I should look like in the periodic table. Very good. Noble gas group number. What is the group number of noble gas? What is the group number of noble gas? What is the group number of noble gas? Group 18. Noble gas belongs to group 18. Note down. Noble gas belongs to group 18. So if somebody will be asking you, yes, the group is exactly group 18. Noble gas belongs to group 18. Noble gas is belonging to which group? Noble gas is belonging to group 18. I hope you might have understood. Group 18. The 18th group belongs to noble gas. The 18th group belongs to noble gas. So if somebody will be asking you which group noble gas belongs to, then your answer should be noble gas belongs to group 18. Your answer should be noble gas belongs to group 18. That's the answer. Noble gas belongs to group 18. Very good. So yes, this is exactly the thing. Electropositive, electronegative we have learned. Receive of electron, giving of electron we have discussed. Now when they are giving, they are becoming positive. When they are taking, they are become negative. So all these important content we have discussed about electropositive and electronegative element. These are very important for all type of tests when you will be learning. So today we are going to do some very important work. See, listen, the most important thing here is these type of things not only comes today. These type of things are very important for your future examinations also. So carbonates compound is one of the most important thing in any type of test series, any type of competitions, any type of places when you are going. So 100% you must be doing it very nicely. Okay, now look at it. Monoatomic ion and polyatomic ion. What is the meaning of monoatomic ion and polyatomic ion? See, monoatomic ion means those ions which are exactly having one positive charge. Understood? So they are forming single atom. Understood? So they are having one positive, two positive charges. They are called as what? Monoatomic ion. Means single atom ions are called as monoatomic ions. Now come on, quickly note down. Single atom ions are considered as monoatomic ions. Note down please. Single atom ions. Single atom ions are called as monoatomic ions. Monoatomic ions. Single ions are termed as monoatomic ions. Understood. So monoatomic ions are considered as what? Single atomic ion. Monoatomic ions are considered as single atomic ions. Now examples of monoatomic ions can be magnesium Mg2 plus. Correct. Now here Mg is one atom only. Mg is one more. How much it is? So Mg is one single atom. So Mg aluminium Al3 plus. Yes, aluminium will become Al3 plus. So 100% it is exactly have the capability to donate. Yes, so it is exactly going to donate. Here Na plus sodium ion. Yes, so sodium is exactly going to give one. Polyatomic ions means many atoms ion. Like when we will be talking about NH4 plus ammonia. Understood. So ammonium. So NH4 plus. So when we talk about NH4 plus, child, good evening. So when we talk about NH4 plus, so here you need to understand that it is exactly giving how many? It is exactly having how many? NH4. Many atoms are present, and these atoms are exactly making ion. So this is considered as what? This is considered as polyatomic ion. This is most important thing. Please kindly don't forget to keep on recording these things. This is not the what you call. This is not a small thing. This is exactly very important for your career point of view also. I hope you might have understood. This chapter is most important. When you will study it very thoroughly, your chemistry will become very easy. I hope you might have understood this one. So now let's talk about this. So we came to know about polyatomic ion. So where Ashish, good evening. So now we are going to understand one thing: polyatomic ion. Ammonium ion NH4 plus is polyatomic ion. Now hydroxide ion OH minus is also polyatomic ion. Understood, beta? Why they are considered as polyatomic ion? Because it is made with many atoms. See, sodium is there. Look here. Sam, here it is sodium NH4 plus NH4. So here more atoms are there plus hydroxide ion OH minus hydroxide and ion made up of two or more atoms held together. And yes, so that's what beta. So when you will be talking about ammonia, Anjali, good morning, good evening. Okay, so this is exactly considered as polyatomic ion. When different atoms will be combining together and their ion formation will be there, then only we are going to consider it as polyatomic ion. What we are going to call it as polyatomic ion. I hope children it is very clear to you. Now let's see some of the examples. Quickly take out your note and start writing this part. This is very important. Super Ashish, congratulations. NIT. Nice. Now Caustic soda is CaUSTIC. Caustic soda. Formula is NaOH. It is called as sodium hydroxide. It is also called as sodium hydroxide. Caustic soda is also called as what, beta? Sodium hydroxide. Wait, this is also called as what? Sodium hydroxide. What it is, beta? Sodium hydroxide. Caustic soda is also called as sodium. Yeah, I'm going to move beta. Just note down this one. Caustic soda is considered as sodium hydroxide. Next is marble. That is calcium carbonate. Calcium hydroxide. Hydrochloric acid. Ammonia. Understood? Yes, note down. Note down. Note down. Chlorine, ammonium chloride, hydrogen peroxide, lead chloride, everything is exactly present here. So how many atoms? They are polyatomic. You see, caustic soda is also polyatomic because it is made with different type of atoms. So since it is made with different type of atoms, it is called as polyatomic. How many atoms are there? Count, finish, Sam. One, two, three. Three atoms. How many atoms are there? One, two, three, four, five. So only it is called as polyatomic. One, two. Here two means yes, this 2 to the 4 plus 1 5. So what it is called as polyatomic. How many atoms are there? 2. Hydrogen and helium. So it is called as very good. How many atoms are there? 3. So what there? 3 no. 3 plus 1 4. So only it is called as tetra. Tetra means 4. What is the meaning of tetra? Tetra means 4. Understood? Now here this is 3 plus 1 4. So it is called as tetra. 2 plus 2 4. So it is called as tetra. Cl2. So it is called as di. Here 4 5 6 is there. So it is called as polyatomic. Quickly note down the names and quickly identify which one is yes. This is very important. Quickly identify all and note down please. So which one is poly, which one is tetra, everything note down please. Quickly do it. I hope you have understood what and all is exactly what name has been given. This is called as caustic soda is sodium hydroxide. Sodium hydroxide and formula is how many atoms are there? See, the number of atoms plays a very crucial role, beta. Because of that, we are writing like this. I hope everybody might have understood. Come on, note down this ammonium chloride. Ammonium chloride is how much it is having? It is considered as polyatomic. What it is considered as? Polyatomic. Note down. Take your time. Note down. We are not in hurry, okay? Finished? Super. Sam, finished? So, beta, now we are going to talk about valency. Valency is one of the most important things. Come on, note down what is the meaning of valency. I'm going to talk about. Okay? How valency is exactly done. I'm going to teach you this. So, give a heading valency. What is the meaning of valency? Valency may be defined as the combining capacity of an element. Write down the definition of valency. The definition of valency is the combining capacity of an element is considered as its valency. The combining capacity of an element is considered as its valency. What is valency? The combining capacity. Means what is the capacity of an element to combine with some other element is exactly considered as its valency. So the combining capacity of an element is here it is written. It is defined as combining capacity of an element. What is valency? Combining capacity of an element is considered as valency. Note down what is combining capacity? Combining capacity plays a very vital role. So I hope yesterday's question set you have exactly got correct now. One question set you have got, you have whatever question sets you are getting, that is totally dependent upon what you are studying. So different type of parameter questions you are going to get, and if these questions you are going to solve and you are going to keep with you, it will be competition and it will be exactly you will be understanding for long term. Okay. So the valency of an element is usually determined by number of electron in the outermost orbit. Number of electron in the outermost orbit. The valency of an element is usually determined by the number of electron in the outermost orbit. It is determined by the number of electron in the outermost orbit. You remember this one. This is very, very important. What is the valency? So valency of an element is determined by the outermost element. Means in an atom, the outermost element will be present. So those outermost orbit elements will be there. These elements will be determining the valency. Understood? I'm going to teach you this one. Get ready for that. So that how valency is exactly determined, I'm going to teach you. So this is because the outermost electrons are largely responsible for chemical behavior. What they are largely responsible for, beta? Chemical behavior. So what type of chemical? Note down this one. This is the most important thing. Nobody will be giving you. You need to remember this. The outer electron are largely responsible for element behavior. The outer electron are largely responsible for chemical behavior. Remember this one. The outer electrons are largely responsible for chemical behavior. As these electrons usually participate in chemical bonding. This is the most important process. You need to understand. You need to remember this one. Remember this part is very, very important. The outer electrons are responsible for chemical behavior because they are only participating in chemical reaction. Understood? They are only responsible for chemical reaction, chemical bonding. They are participating in chemical bonding. So since they are participating in chemical bonding means they are very, very important and they only determine the chemical behavior. Note down. Note down, the outer electrons are largely responsible for chemical behavior. The outer electrons are largely responsible for chemical behavior as these electrons usually participate in chemical bonding. Where they are participating? In chemical bonding. So they are only responsible and they are only important for chemical bonding. So this is the most important answer everybody will be asking you for. So what is more responsible? The outermost electron that is participating in chemical reaction, they are responsible for bonding. They are responsible for bonding, and that's the most important thing you must remember. I hope you might have understood this one. So the outermost orbit is responsible because the outermost orbit, how many electrons will be there? They will be responsible for type of bonding. I'm going to show you how they are responsible for chemical bonding, in which way they are responsible for outer bonding. Yes, Beta Tanisha, absolutely correct. It's the electron which is responsible. Very good. So now variation of valency in a period. So definitely in a period, valency variation will be there. On moving from left to right in each short period, the valency of element first increases from 1 to 4 and then becomes 0. The trend for the element of third period is shown in below. So I am just going to show you 1, 2, 3, 4, 3, 2, 1, 0. This is exactly how they are going, valency. So I'm going to tell you how the valency is exactly coming. Just stay tuned. I'm going to explain you. Are you all ready for it? Are you all ready for it? Come on, let's start the work. Are you all ready? Means I'm going to start the work. Tanisha, Beta, just start writing the content and write in a very appropriate way. So now look at it. I'm going to start this work. First, I'm going to teach you how valency is exactly. Yes, beta. So SPDF rule or KLMN cell rule. So first, energy orbital I'm going to teach you. And according to an energy orbital, what is the capacity of each energy? Each orbital also means each orbit also I'm going to explain you. Are you all ready for it? So just understand this one. First one, what I'm going to do is I'll be talking about 2n square rule. So write 2n square rule, where n is orbit. What is n? N is orbit. So this rule is considered as 2n square rule. So what is the meaning of this 2n square rule? Let's check this one out. What is the meaning of this 2n square rule? Let's check this part out. 2n square rule. So we know that an atom is having a nucleus. Now nucleus is having neutron plus proton. Understood? Now it will be orbited by orbits. Orbit number 1, orbit number 2, orbit number 3, orbit number 4, orbit number 5. So for you, SPDF rule you don't have to study. You understand K elements. So first orbit K. Understood? Second L, M, N, O. So like this orbit works. First orbit, second orbit, third orbit, fourth orbit. It is written as K, L, M, N, O. So the capacity of orbits to have electron is given by 2n square. It is given by 2n square. Note down, the capacity of orbit to have electron is given by 2n square. Who has given this orbit and who has given this capacity? See, you remember one thing, children. These things are very, very important. See, other subjects are okay, but the most important thing is that these things are stronger in you. Then yes, not only chapter, you need to solve many questions. So like this, it is very, very difficult. Now just check this one out. Now please pay attention here. Now please pay attention here. Check this one out. First orbit. First orbit is K shell. For K shell, n will be equal to K shell. We call it as shell. So for K shell, n is equal to 1. What is the value of n? Value of n for K shell? 1. So 2n square is 2 into 1 square. It is coming as 2. Note down. For L shell, n is coming as 2. N is coming as how much, beta? 2. So here 2 into 2 square. So it is coming as 8. So second orbit, first orbit understood. Third orbit, KLM. M shell. It is 2 into n is value is coming as 3. So it is 2 into 3 square, 18. Fourth M shell. It is 2 into 4 square, that is 32 electrons. So how many electrons it can accommodate? First orbit 2 electrons, second orbit 8 electrons, third orbit 18 electrons, fourth orbit 32 electrons. And O shell. So for O shell, how much electron it is going to accept? So we will write 2 into, how many is there? 1, 2, 3, 4. N is equal to 3 is there, N is equal to 4 is there. Now here N is equal to 5 is there. So here it will come 2 into 5 square. So 50 electrons. Understood? How many electrons it can accommodate? 50 electrons. Note down. This is the most important thing. Yes, beta. 50 electrons. I hope you might have understood. So 50 electrons are coming there. This is coming as 50 electrons. I hope you might have understood it. Now we will be talking about according to the orbit how it is exactly going. Hmm. Huh? MN, yes, beta. KLMN, no, beta, that is the orbit circle. But for me, it became like that. Huh? No, beta, LMNO like that. I just wrote like that, space was not there. Huh? So this is KLMNO. Understood. So they are different orbit. Yes, Kanish, today you are late, beta. So we understood this one. So after understanding this one, now let's solve the next part. So now get ready for the next one. So K, L, M, N, O. We have done all different equations. So now we know the capacity of every orbit. Now we are having information of capacity of every orbit. So once we are having information and capacity of every orbit, yes, beta. Okay. So now we are going to do one more. Is it done till here? Now we are going to talk about till 20 atomic numbers. So are you all ready? So first we are going to talk about hydrogen, helium, their structure. So now we will make a table. So get ready for making a table. It will take time, but the table will be presenting everything. Okay? We will draw the structure also. Okay? So this is K, L, M, K, L, M, N, O. So here maximum capacity is 2, 8, 18. Correct, no? Next one is 32 and here it is 50. But are we going to get that much is possible or not? We will see. Okay. So first we are going to talk about hydrogen. Hydrogen atomic number is 1. So that means first orbit only it will fill. How much is the capacity? 1. So now how the hydrogen atom will look like? So let's talk about hydrogen atom. So this is exactly the nucleus of hydrogen. Now when we are talking about hydrogen, first orbit is having how many electrons? Only one electron. Got it? So this is hydrogen and hydrogen first orbit is one electron. So what is its valency? Its valency is 1. Okay. So once its valency is 1, now we are going to talk about since its valency is 1, please pay attention and try to understand this one. Its valency is how much beta? 1. So definitely it can give and take. It can give and take. So hydrogen can give electron also and hydrogen can take electron also. So it can give one electron also it can take one electron to become like helium, which is a noble gas. N क्या है? Ng. Ng means noble gas. To become like Ng. Ng is considered as what beta? Noble gas. To become like noble gas, it can take one electron and it can give one electron. That is the most important part. It can take one electron, it can give one electron. So first we talked about hydrogen. What is the valency of hydrogen? 1. Because outermost orbit, how many electrons are there? Only 1. So since outermost orbit, only 1 electrons is there. So its valency is what beta? 1. Okay. I hope you might have understood this one. Good. So now we are going to talk about helium. Second one is helium. Its atomic number is 2. So first orbit electron is 2. So that means now we are going to draw the structure of helium. Nucleus will be there. First orbit, how many electrons are there? 2 electrons. So since first orbit 2 electrons is there, now here you need to understand one thing. What is the capacity of first orbit? The capacity of first orbit is 2 electrons. What is the capacity of first orbit? 2 electrons. So helium, this capacity is reached. So what is its valency? Its valency is 0. What is its valency? Its valency. Because it is stable now. It will not combine with anything. It is a stable part. It will not combine with anything. So since it is a stable part, it does not combine with anything. Its valency will become 0. So write down valency 0. Because it is stable. First orbit, what is the capacity? 2 electrons. So first orbit, the capacity was to having 2 electrons. Now 2 electrons is already reached. So since 2 electrons is already reached, why they will combine? So since 2 electrons are already reached, they will not combine. So hence the 2 electrons are already reached, it will not at all combine. So its capacity is coming as exactly 0. So its valency will become 0. Its valency is coming as 0. What is its valency? 0. So helium valency is coming as 0. Now we are going to talk about lithium. So lithium atomic number is 3. So 2, 1. Understood? 2, 1. Very carefully you need to draw everything. Now it is entering second step. Second orbit. Which orbit it is entering? Second orbit. Now hydrogen and helium done. Note down, take your time. I am not at all in hurry. One time you will understand, every time you will understand. Yes, better. So it is coming 1 and 2, here 2 and 1 is there. First orbit 2 electron, second orbit 1 electron condition. First orbit 2 electron, second orbit 1 electron. Okay, remember like that. First orbit 2 electron, second orbit 1 electron. Absolutely correct, Arunisha. Its valency is coming as 1 beta. Super. So since outermost orbit only 1 electron is there, it will only donate. It will only donate. It will not accept. It will only donate. Absolute. Yes, Tanisha, absolutely correct. Beta. We are going to go with this one. So now we are going to understand about lithium. So how lithium is going to respond? Lithium outermost orbit. How many electrons are there? 1 electron. So lithium outermost orbit, 1 electron is there. So since what is the valency? So now this is saturated. First orbit is satisfied. So since first orbit is electrically neutral, now the capacity of 2 electron is filled in the first orbit. Now first orbit will not take part in chemical reaction. Orbit 1 satisfied, you write here. Orbit 1, yes. Orbit 1, orbit K or K shell, orbit 1, that is K shell is saturated, satisfied, because it is having all 2 electrons. 2 electrons means now it is satisfied. K shell capacity 2. So it is saturated. Its capacity is 2. So it is K shell capacity is 2. So it is saturated. K shell capacity is what beta? 2. So it is saturated. K shell capacity is 2. So it is saturated beta. Now outermost orbit 1 electron is there. How many electrons are there? 1 electron. So since 1 electron is there, so 1 electron is there. So therefore its valency is 1. What is its valency beta? 1. So that means it will give electron or take electron? It will give electron. It will give it because inner orbit is saturated. Na? Outer orbit is 1. So it will give electron. It will give electron. So since it is exactly saturated, it will give electron. Its valency is plus 1. It is saturated, so it will give electron. Remember this one. It is going to take or give? Give electron. Remember this one. It is going to give electron. That's the most important thing. Understood? So it is exactly going to give electron. You need to remember this one. So its valency is 1. So since its valency is 1, it will exactly give electron. And when it will give, it will gain the nearest noble gas configuration of. So after giving one electron, it will gain the nearest noble gas configuration of helium. After giving one electron, it will become like what, beta? Yes, it will become like beta, it will become like helium. Understood? It will become like helium. That's the most important part. So after giving one electron, it will become like helium. Got it? So you need to understand this one. कि whenever helium, what is electron, what is proton? They are subatomic particles of an atom. Understood? So subatomic particles are what? They are those smaller minute particles of an atom which is exactly having distinct characteristics like their atomic number, their atomic mass. But yes, they play a very vital role in giving the physical and chemical properties of an element. So you must remember, if somebody will be asking you about, yes, I have given your answer. So if somebody will be asking you about this question, you must remember this one. That somebody will be asking you about electron, you say that it is the subatomic particle and electrons are negatively charged. 1.6 into 10 to the power minus 18 is coulomb is the charge of every single electron. Understood? And for proton it will become plus. So you need to understand when electron is present in the extra nuclear part in the outermost orbit, protons are present in the nucleus. Okay? Configuration is with the attainment of this order. Attainment of the order here is configuration. So you need to understand that configuration of helium is 2 electron. Configuration of helium is having 2 electron in the outermost orbit. So once lithium will give 1 electron, so this orbit will be moved. So then what will be left? Only inner orbit will be left. I hope you might have understood. At that particular moment, only what will be left later? Inner orbit will be left. So that's the most important thing. So always every element of the periodic table, they want to become like whom? Noble gases, because they are the ideal gases for them. What they are better? Ideal gases, and everyone wants to become like them only. Understood? Now, can we go for the next one? So lithium can have configuration of helium. After losing how many electrons? One or two? Very good. One electrons. Now, beta, hydrogen, helium, lithium, beryllium. Beryllium atomic number is 4. So, how it will be? 2 and 2. So, that is first orbit to electrically neutral because it is exactly going to satisfy. I have written everything. All simple, short information I have given. So, now how beryllium will be looking like and what and what are the properties of beryllium. Understood the beta? So, now look here, beta. Kanish, Tanisha, understand this part here. So if this is the orbit, and beta, this is the nucleus, and this is the first orbit, and this is the second orbit. We know this is K shell, and this is L shell. So what is the capacity of having electron in K shell? 2 electrons. So we have 2 electrons satisfied in K shell. L shell, how many electrons capacity is there? 2 electrons capacity is there. So since it is having 2 electrons capacity, so now it is having 2 electrons. So K shell and L shell is having how many electrons capacity? Shells are there in total, beta. You can draw according to that Goldberry scheme. You need to understand that key element. Till now, you have 170 elements, and it is going on by man-made element. So K, L, M, N, O, maximum you can do like that. Key capacity is 2, L at 18, 32, 50. You count it this much only. 10, here 20, 0, 5, 8, 9, 10, 11. So here itself it is satisfied. You need to go like periods. It is coming like periods only. 5, 6, 7. Understood? So now look here. We will be understanding lithium. So sorry, we are going to talk about beryllium. So beryllium valency is exactly how much? Beta, can you tell me what is the valency? What is the valency of beryllium? 2. Because it is exactly going to, it can lose how many electrons? 2 electrons. So if it will lose 2 electrons, whom it will look like? After beryllium will lose 2 electrons. It will look like whom? Helium. Because these two electrons will not be there. Outer these two electrons will not be there. So it will look like whom? It will look like helium. Understood? So it will gain the nearest noble gas configuration of which element? Helium. Noble gas, helium. So definitely its valency is what, beta? 2. Its valency is 2. Till here is it clear, beta? Till here it is clear. So once giving 2 electron, it will become what? Electropositive. What it will become? Electropositive. Now we are going to talk about boron. Boron atomic number is 5. It will become 2, 3. So how many maximum element boron can give, beta? 3. Boron will give how many? 3. You must remember, same structure will be there. Here boron, 1 more electron. Keep some distance between electron because electron negatively charged, so they will repel. So a negative charge repulsion is also there. So here boron structure will be written like this. So for boron, this is exactly for boron. Boron valency will be what? K, L. K is 2, L is 3. So valency for boron will be how much, beta? 3. Got it? So boron will give what? Outermost orbit. Beryllium is 2, boron is 3. So valency is 3. So how many electrons it can give, beta? It can give 3 electrons. All 3 electrons now. Understood? It will give how many electrons? 3 electrons. So that means boron can become B3 plus by giving how many electrons? 3 electrons. And once it will give 3 electrons, how many electrons it will have? 2 electrons. So it will gain the nearest noble gas configuration of whom? So B3 plus will look like whom? Helium. Understood? So after giving how many electrons, beta? 3 electrons. So valency. Yes, first outermost orbit will be fully resolved, na beta, because it has given how many electrons? 3 electrons. Valency is outermost electron. Valency is not innermost electron. Surya, huh? Yes, and then only 2 will be left. So right now, how much is present in the outermost orbit? 3. So its valency will become 3. Whatever is present in outermost, its valency will become like this. Understood? Here outermost was 1, so its valency is 1. Here its valency is 0 because octet rule satisfied. Here outermost orbit is octet rule means satisfying K11 property. So once the octet rule is satisfied, it is exactly coming as 0. Hello Surya. Suryavanshi. Yes, yesterday also you were there. No? Yes, LA. LA. I hope you might have understood till here. So hydrogen, helium, lithium, beryllium, boron, carbon. Now next comes carbon. Shall we start with carbon? So for carbon, how we are going to respond? Yes? Yeah, that much shouting. Hey, what you people are doing? Who's that kid? Too much noise they are creating. Now look here. So this is exactly valency is 3. Now comes the valency 4. We are going to talk about carbon. Now carbon, see, for carbon, K cell is having 2 electrons, L shell is having 4 electrons. Understood? So its valency 8. Its valency is coming as 4. Its valency is coming as how much, beta? Its valency is coming as 4. Remember this one? Its valency is 4. But it can neither take 4. Yes, what to do? They are shouting too much outside. So it's outer. See, it can neither share. It is exactly not going to give 4 and it is not going to take 4. The biggest problem with this is it can neither give nor take. I hope you might have understood. Yes, it is exactly having valency 4. What is the valency of carbon? The valency of carbon is 4. But the most important thing is we cannot expect carbon to give all its 4 electrons. Not possible. The structure will collapse. It can neither take 4 electrons nor give 4 electrons. So those elements whose valency is 4, they only share. They are not taking and they are not giving also. So I hope it is clear for you. So they are only sharing. Sharing is caring for them. So right, for carbon, they will share 4 electrons. They will share 4 electrons. So that is share. They will share 4 electrons. Okay? Can't give, can't take. Can't give, can't take. So those elements in the periodic table whose valency is 4, they can neither giving nor taking. They can't give, they can't take. They can only share. They can only what, beta? Share. So there for them sharing of 4 electron is done. For them what is done? Sharing of 4 electrons is done for them. Yes. So they will be sharing the 4 electrons. Remember this one. They will be sharing the 4 electrons. Now, beta, we need to understand here if we are going to write about carbon. Carbon is 2 and 4. Valency is how much? 4. Now comes hydrogen, helium, lithium, beryllium, boron, carbon. Next comes nitrogen. So if somebody will be asking you about nitrogen, then how we are going to say? For nitrogen, exactly it is coming as 2 and 5. The moment it is crossing 5, crossing 4. The moment it is crossing 4, you need to remember one thing. The moment it is crossing 4, it will not be considered as valency 5. It will be considered as valency 3. Understood? So now all of them will giving now. Now from nitrogen, they will start taking. Now understand about nitrogen story. So once upon a time there was a nitrogen. That's good. Nitrogen atomic number was, what is the carbon atomic number is 6, nitrogen atomic number is 7. So once upon a time there was a nitrogen. So nitrogen first orbit is exactly having how many electrons? 2 electrons. Understood? Now second orbit is having how many electrons? It will have 5 electrons. How many it will have? 1, 2, 3, 4, 5 electrons. It is having how many electrons, beta? It is having 5 electrons. That is still how many places is left for? 3. Understood? So here, yes, I am telling the story of nitrogen. Now nitrogen fell in love with the nearest noble gas. Understood? Neon. Neon was very beautiful and neon number of atoms were 10. Now nitrogen was having 7. Problem is nitrogen fell in love with neon. Now nitrogen wants to become like neon because how nitrogen can become like neon? So if nitrogen will take 3 electrons, then it will become like neon. I hope you might have understood. So once the nitrogen will take 3 electron, nitrogen fell in love with who? Neon. So neon is stable. Neon is stable, very happy, very beautiful, and very, very stable. So this nitrogen wants to become like neon. So since the nitrogen wants to become like neon, Nitrogen wanted 3 electrons. How many electrons? 3 electrons. So once it will receive this 1, 2, 3 electron, its outermost orbit will have how many electrons? 3 electrons. But nitrogen is not giving. Nitrogen here is needing. So that means given nitrogen will take 3 electrons, it will become N3 minus. Understood? So its valency is how much? Its valency is 3. But it is not giving, it is taking. It is taking 3. So its valency will become 3. Understood? So its valency is coming as how much, beta? Its valency is coming as 3. Why? Because it was needing. It was needing. It was not giving. So only it is considered as electronegative. Understood? Electronegative means those elements in the periodic table who takes electrons to gain the nearest noble gas configuration, they are considered as electronegative. What they are considered as, beta? Electronegative. So here nitrogen wants to gain the nearest noble gas configuration of neon. Neon is having 10. So 100% nitrogen was looking forward for 3 electrons. So once it will be looking forward for 3 electrons, what will happen? Yes, electronegative, absolutely. So once it will be exactly taking 3 electrons, it will become N3 minus. Understood? So what is the valency? Here valency is 3. But this 3 is because of taking 3 and stabilizing. That's why the valency definition is combining capacity of an element. Atom, combining capacity of an atom of the element. Understood? So it's the combining capacity of the atom. So outermost orbit, how much electrons are there? It will keep on adjusting because they want to become like, they want to gain the nearest noble gas configuration. So since they want to attain the nearest noble gas configuration, they can either be giving or they can either be taking. I hope everybody might have understood. How was the class today? Did you understood it nicely? Yes, beta.
The K-shell become two in here, it become the lower gas. In the LR, it becomes same, then this should also become
noble. Yes. We'll see now. We will see. We'll just see here. Now nitrogen, oxygen, 8, fluorine, 9, neon, 10. So for neon, it will be 2 and 8. Satisfied. Neutral. Understood? So now 2 plus 8. Our capacity was 8, it reached 8. So neon is a noble gas. Helium is a noble gas. What is the valency of neon? 0. What is the valency of oxygen? 2. Because for oxygen, only one extra work will be there. Now, if we talked about distance of valencies, did you note this one? Done now? Did you note it? So now we are going to talk about its valency. Now we are going to talk about oxygen. So now if we are going to talk about oxygen, so oxygen you remember when somebody will talk about oxygen atomic number is 8. So that means how much it is needing? 2. So that means now for oxygen outermost orbit, how many electrons are there? 6. How much it is needing? 2 more. So what is its valency? Oxygen valency will become what, beta? 2. Because it is exactly needing how many electrons? It is needing 2 electrons. How much electrons it is needing? 2 electrons. So here oxygen will get 2 electrons and it will become O2 minus. Understood? So is it electropositive or electronegative? It is electronegative because it is receiving. So those who receive electrons, so its valency is how much, beta? 2. The moment it will take 2 electrons, whom it will become like? Neon. So that means O2 minus looks like whom? Neon. Because O2 minus is having how many electrons? 10 electrons. Neon is having how many electrons? 10 electrons. So both are having 10 electrons, so they will become like each other. I hope you might have understood, beta. So after giving or taking electrons, they look like same. I hope you might have understood this part. Shall we go for the next one, please? How was the class? Did you learn it nicely? Now comes fluorine. So if somebody will talk about fluorine, fluorine atomic number is 9. Atomic number is 9. So outermost orbit, how many electrons will be there? 7 electrons will be there. For fluorine, how many electrons will be there? 7 electrons will be there. So for fluorine, valency will become 1. So that means fluorine will be needing only 1 electron and it will become F minus. So its valency will become 1. What is the valency of fluorine? 1. What is the valency of fluorine? 1. Did you understand? It came like how it started with one very nice note. It started with valency 1 and then 0, then 1, 2, 3, 4. After that, 3, 2, 1, 0. Check. Valency how it started? 1, 0. Again 1, 2, 3, 4. After that, 3, 2, 1, 0. Correct na valency? After 1, 0, then 1, 2, 3, 4, then 3, 2, 1, 0. Valency plays like this. So in tomorrow's class, we are going to remember how to get the valency of other elements. Is it done? Nicely. How many elements we have finished? 10. Neon. Neon also note down. No? Neon is 2 and 8. Note down for neon. Neon is coming as what letter? 10. So 110 is there means it is completely satisfied. Completely satisfied means it is not having any, it is exactly 10. So it is neutral. Valency is 0. What is the valency of neon? 0. Yes, done? Super. So this was today's class. I hope you might have enjoyed today's class. Chemistry classes hereafter all the chapters are very interesting. We'll start revision soon. All the test series part questions today also you will get. I hope your questions are ready. It will reach you soon for test today. Hmm? No, to Rupanti or you have to send it to Umanti or Rupanti or Mansi. 3 people they can check your corrections. They are having the question sets and solutions. Okay. If they will be having any doubt, please I will be giving because questions and solutions they are having. Bye everyone.